Okay, so as we're going through these, this is again just kind of backing up to make sure we've got everything here. Very first thing talks about linear relations. That linear relations is just on a straight line. And as long as you go through that one, there's going to be an equation that we have that's set up for this thing. Um, and the one thing that we do for this one for standard form, which we really don't use a whole lot, but you'll see it some, is ax plus by equals c. Okay, and it tells you that if you're going to do it this way, a, b, and c are integers, which means there's no fractions, there's no decimals, it's all whole numbers. Uh, it's nicer if the a value is positive, just makes it kind of flow a little bit better. The b and the c values, those could be negative, they could be positive, but the main thing is that they're integers. Which again, if it's integers, that means it's all whole numbers, no decimals, no fractions, which is what most people are going to like for that thing. Okay, so very first thing that we're going to do is we're going to take the equations we've got here. First thing is we're just going to practice rewriting them, just working with our math skills a little bit, so that we can get in this form where we've got ax plus by is equal to c. Again, we want the a value basically to be positive, so that just makes this thing flow a little bit better. For number one, it's pretty much almost there. The only difference is in this case the a value is negative. So to make that equation then be positive, we just need to take everything here and multiply it by -1. Okay, so multiplying by -1, basically we just change all the signs. That'll make that 5x minus 6y equals 12. And depending on Math Excel, sometimes that may be one of those, they may ask you to write it this way, and they may come back and then have you tell me what the A and the B and the C values are. Sometimes they do that, a lot of times they won't. If they happen to do that, your A value would be 5, your B value would be -6, and then your C value would be 12. Okay. All right. Number two, that's probably the way that we actually have seen most everything. That's in slope intercept form. But again, they're asking us to go back and rewrite this in standard form. So we've got to get the x's and the y's on the same side. So for that one, we need to move the x over to the left. So we need to subtract -2x from both sides. And again, if it's been a little while, just remember with the equation symbols that if you do something on the right-hand side by subtracting away the 2x, you've got to balance it out by doing the exact same thing on the left-hand side. Okay, so if we do that, that'll give us -2x. That would be a positive y, so plus y equals -9. And now that part looks a lot like the part we had here. We just need to change this first value from negative to positive, which basically means we're going to take everything here and multiply it by -1. Okay. And again, multiply by -1, the shortcut is you just change all the signs. So I'd make that 2x minus y equals 9. Okay, number three, pretty much already there. Just one little simple thing to do because you've got the x's and y together. The x is positive. So for that one, we would just add 24. So 9x plus 6y equals 24. All right, number four. Again, get the x's and y's on the same side. We need to get rid of this x and move it over here to the left-hand side. So we'll basically need to do, if it's a minus, we'll add 7 to cancel that out. So that'll leave us with 7x plus 7y equals 7. Okay, now the one little extra tie-in for this one. That you don't really get this one a lot, but back up here, we've got it so the a value is 1. We've got the x's and y's over here. Last little thing it says, the greatest common factor of a, b, and c is 1. So in a problem like this, they're all 7, so you could factor out the 7. So basically, we can go through and divide everything by 7 in this case. So we can divide, everything by 7. That would cancel it out. So if we do that, that would leave us with x plus y equals 1. So basically, they're saying, all right, if you have a greatest common factor, if you've got something in common with all the numbers, go ahead and divide that number out of each of the numbers just to make it as small as possible. All right, number 5 is good because how many people really like fractions? Okay, that's what I thought. Nobody does, right? Yeah. Somebody, and there's somebody who's saying I do, but they don't want to raise their hands because they don't want to like the weird person in the classroom. Okay, so if you got these, you've got 3/4 x minus 1/3 y equals 1. Standard form, no fractions, which is what everybody likes because nobody likes fractions. Even if you were Mr. Bird and you were stuck in fraction land, you probably still didn't like it then. Okay, so we've got to basically get rid of the fractions here. So what we're going to do, and kind of flash back to some stuff, is we've got to figure out what the least common denominator is, which means you're working with just your denominators. You're working with a 4 and a 3. And a couple of different ways you can do it. If they're two different numbers and they're not multiples of each other, the easiest way to get the least common denominator is just to multiply those two things together. So let's do 4 times 3, make it 12. And if we want to get rid of fractions, we're just going to take that least common denominator and we're going to multiply every single number by 12. So it's 12 times 3/4 x minus 12 times the 1/3 y equals 1 times the 12. Okay. Now, exactly where you put the 12s, it doesn't really matter for these. I'm putting the 12s in front just so that when we go to cancel it out, it's a little bit easier. Because what you should kind of see is that this one, 4 going to 12 3 times. 3 going to 12 4 times. And then there's nothing to cancel here. So then the rest of the way, you're just kind of working it out. So now you've got 3 times 3 for 9x. 4 times 1 for 4y. And then 1 times 12 for 12. Okay, and then one more fraction. And this one's a little bit easier because there's only one denominator that's here. So that makes it really easy that your least common denominator is 6. So we're going to take every single number here and multiply it by 6. So it's 6 times 16x equals 6 times y minus 2 times 6. Okay, those straight cancel, basically just leave you with 1s there. So that's just 1x. And then for there, nothing to cancel on the right-hand side, so it's just 6y minus 12. Okay, and then the last thing we want to do is move the y value from over here back over here to the left-hand side. So for that last piece, we're going to subtract 6y from both sides. Okay, and if it's 1x, you don't have to put the 1 there, so we can just leave it as x minus 6y equals negative 12. Okay, and biggest thing really in that case, it does show us what standard form is, but again, a lot of times we don't use standard form just because there's other things that work better. But in this case, what we're doing, it's really just kind of reviewing least common denominator, reviewing, remember when solving equations, working both sides, just all those little things that we've got to do, just moving some stuff around, multiplying distributed property. It's just all those little things that you do when you're working through math problems. So it's just, kind of helping us to brush off some of the skills that you may have not used in a while and start using them again. All right, so next thing we've got is slope-intercept form, and that's the equation that we use more than probably most of the time because it says linear equations are often written in slope-intercept form, and for those, that is the y equals mx plus b. All right, now, and there's a small movement, and I like this movement to actually kind of get away from writing it this way to writing it this way, b plus mx. And here's kind of why I kind of like that way first. Um, M is the slope, and B is the y-intercept. And pretty much every textbook you're going to have, they're going to lean on this equation. I kind of like this one better because to me, and I always wanted stuff to make sense. So I was like, well, why is M slope? And why is the y-intercept B? I'm like, there's got to be a reason behind it. And I don't know if this is a reason or not, but this is what I made make sense in my head. The M in this case, when you talk about M being the slope, I think about that. That is the movement to the next point. That if you kind of look below this one, it says slope is the constant rate of change between the points. Think rise over run, which is what we're talking about here. That remember that tells you to go up 5 and over 2, or down 6 and over 7, whatever it is. So to me, the M is a slope, but to me, the M stands for the movement because it tells you how to move to get to the next point. You go up 5 and over 3, or you go down 4 and over 1, or whatever it is you're going to do. So to me, it's always the movement of how you get from one point to the next point. The B value, which is the y-intercept, it tells you where to begin on the y-axis. So the reason to me that they always called it the B value is that tells you where to begin because that's the beginning point that you start with on the y-axis when you're working through something. And to me, if it's the beginning point, shouldn't you start there? So this is kind of why I think, and I actually heard another teacher talk about this a little while back, that she actually said that was if we're beginning with the B value, shouldn't that be the first thing in our equation? I'm like, yeah. And so I think maybe, I don't know, it might eventually get to where instead of writing it this way, we write it this way because you begin with the first number and then you move this value to get to the next number, which makes sense. So you start here and you move this much. This one, you start back here and you go back and move over here. So every book I've ever seen, it's written this way, but to me, this makes more sense because you begin here and you move this way to get to the next point. Okay. And again, it may not be in my lifetime that'll happen, but maybe one day it'll get there. And then you'll be old and you'll say, well, we did it my way back then. We always did MX plus B. You and your fancy B plus MX ways that y'all doing now. I don't understand it. And then you can be, like your parents and your grandparents. Talk about it that way. Okay, so anyway. All right, so slope. It's constant rate of change. It's rise over run. So when we talk about slope, and there's not actually, a box here, we'll do this, but we'll do this. It says there are actually 4 different types of slope that we can look at. You can have positive slope. You can have negative slope. You can have a zero slope. And depending on where it's written and how it's said, you can either call it undefined. Some places will call that no slope. It just depends on the book and how they're looking at it and what's kind of going to be with it there. Okay, and like a lot of other things in life, somebody just had to come up with the rule for which way we're going to go with this one. Kind of like with cars. Who decided we were going to drive on the right-hand side of the road? Don't know, right? It just kind of happened that way. Other countries, somebody said, all right, we're going to drive on the left-hand side of the road. And that's just the way it was. Slope is kind of one of those things, too, that somebody just said that when we're going to work with slope, that you have to think about what it's doing on the right-hand side of the graph. So when you think about a positive slope, positive, it should be rising to the right or rises to the right. So if you're going to draw a graph, you need to have a right side that's pointed up. If it's negative, again, the right side kind of tells you what it's going to do. If it's negative, that means it should be falling to the right, so it falls to the right side of the graph. Okay, and everybody usually remembers those because it's that's stuff y'all done since probably sixth grade, maybe even seventh grade. If not seventh grade, for sure. Zero undefined. That's the two that usually get people because they're like, oh, I don't remember, because this is where it kind of starts getting tough. Because you got one that's going to be horizontal and one that's going to be vertical, and we got to figure out which one it is. Here's the trick I finally figured out of which one it was. Because when I was in y'all's shoes, I remembered it just long enough for the test, and then it was gone, and I didn't remember it. When I had to actually start teaching it, I was like, okay, I can't just memorize it because somebody asked me a question 3 days later, and if I don't know the answer, then I'm in trouble and I look like an idiot. So I had to start figuring out ways to make these things make sense. And what I finally figured out was one's horizontal, one's vertical. There's not a whole lot of Z's in the alphabet. So I kind of caught on the thing, oh, if it's zero slope, there is a Z in horizontal. And it just works out conveniently enough that if you have a zero slope line, it is going to be a horizontal line. Which means if you memorize that one, the other one has to be the other way. So I didn't worry about memorizing this one. I just caught on the fact that, oh, zero is horizontal. So if it's vertical, it's got to be the other answer. So then undefined or no slope, that's going to be vertical, which means it'll look something like that. Might not be the best vertical line in the world there, but I think I had some people ask me one time or told me one time that their teacher told them that think about rolling the ball, and whichever way the ball rolls, that's the way. And again, you got to roll it to the right side. Whichever way the ball rolls, that's what it's going to do. So this one, if you roll it, you're going to roll it up the hill, so that makes it positive. This one, if you roll it, it's down the hill, so it's negative. So we've got positive, negative. Again, the two over here that's kind of trick questions, if you want to call them that, is that somebody said, all right, if you roll this ball, it's not going up, it's not going down, it's just staying flat. So they were like, that's why it's zero, because it's not up or down, it's just there. And can you roll a ball against a vertical wall? Can't, can you? You throw it at it, it's just going to bounce off of it. So they're like, it's not possible. So if it's not possible, then it's no slope. And I was like, okay, well, that makes sense because it's rolling a ball and seeing what it does when it goes the right side. There is no right side, so there is no roll, so there's no slope. I was like, okay, well, that makes sense. Okay, all right, so we do need the equation. So there's kind of the basics of it. When we're talking about equations, we're going to put it in the box that's over here. Since slope is m, then for the equation for m, and you can do this one of two ways. You can either do it as y2 minus y1 over x2 minus x1. Or you can do y1 minus y2 over x1 minus x2. And I've gotten, as I've done this more and more, I kind of like this second. I know this is one the book always shows every single time. I kind of like this one because I like putting the first things first and the second things second because that means I have less chance of messing some stuff up. So it really doesn't matter, which one you use. Just one of these two. A lot of times I'm going to use this one just because I like to put the first things first and the second things second. The only difference in the answer is if this was a negative number, if this answer was negative 6 over 5, if you do it this way, you get 5 over negative 6. I'm sorry. Hey, whoa. Try that again. 6 over negative 5. So all that it's going to do is if the problem is negative, it's going to move the negative from the top to the bottom, but it's still negative. It doesn't matter where the negative is. It's still going to make it a negative number if you were doing that. So that's all it's really going to do. It's just going to change where the sign is, but it's still going to make the number still be the exact same thing. So whichever equation you use, it doesn't really matter which one you use there. Okay. All right. So flip over to the back side. And here's where we get a little bit of practice going back and work with these. And again, the biggest thing we're going to do is we're going to do slope intercept form. So that is, and again, we're going to stick with the y equals mx plus b because that's how everybody does it. To me, it'd make more sense to do b plus mx, but we're just going to, we're going to stick with what everybody says it's going to be. Okay, so for the first ones here, biggest thing we're going to do before we graph these is we're going to say what the m and the b values are. So in this case, with this being y equals mx plus b, our m is 2/5, and our b is at 7. All right, actually, let's do this. Let's make one little change here, because if we do that one, we're going to make one small change. Because if we start this thing, because the b value tells you where to start, right? It tells you where to begin on the y-axis. So you're going to start on this axis because that's the y-intercept. If we start this thing at 7, that puts us up here. What happens when we try to go, we've got 2/5, right? Which means we're going up 2 and then right 5. What happens when we go up 2 and over 5? Yeah, there's no more graph, right? So now we'll show you what to do with that in just a second. But for this one, let's just change this from a +7 for the minute. Let's just change it to a -7 to make it easier to graph. Okay, so now we're going to begin at -7. So 7. So that should put us right there. And then again, since it's positive, we're going to go up 2 and then over 5. So up 2 and over 1, 2, 3, 4, 5. Should put you there. And then just connect your dots. Okay, now, and this will happen occasionally. If this had stayed +7 like it was originally, if you'd started here, if you cannot go up 2 and over 5, which would have been about here, but it's off the graph. If you ever get one that's off the graph, either at the top or bottom, just do everything backwards. So instead of going up 2 and right 5 from this point, we're going to go backwards. We're going to go down 2 and then left 5. 1, 2, 3, 4, 5. You know, do that right? 1, 2. Yeah, that's it. Okay, and that way, if we had graphed that one, it would have connected, and that way it would have kind of gone right about to that point was going to be there. Okay. Now, that doesn't happen a lot, but it does happen. So if you do happen to get a problem where it goes open over the graph, then just do everything backwards so that everything kind of stays in that same line. So normally if we're supposed to go up 2 and over 5, but we're off the graph, just do everything opposite. Go down 2 and then left 5, and that way they'll still stay in connection there. Okay, number 8, it's f of x equals, but this is actually like function form. So where you got the f of x equals, that's still the same thing as y equals. And we'll actually talk about that not in the next couple of days, but sometime down the road we'll talk about the f of x and what that means for that part. But we'll just go ahead and think about y equals -x plus 2. So in that case, our m value would be at -1, and our b value would be at 2. Okay, first thing what the slope is. It's not a fraction. So how do you take any number and make it a fraction? Yeah, thanks for that. Just put it over 1, right? So the easiest way to make anything a fraction is just to put it over 1. So if they give you a whole number, doesn't matter what it is, just think about it being over 1. And people usually go, so if the slope is just a whole number, then it automatically is over 1? Yeah, it is. If they give you a whole number, it just automatically means you have to go over 1 for that part. So that means we're going down 1 and then right 1. But again, we're going to start at the b value of 2, so we're going to start at 2 and then go down 1 and then to the right 1. Okay, and you probably had teachers in the past that said, well, you have to do at least 3 points. Okay, that's fine, but for what we're doing, we don't have to do that. So as long as we've got the slope, we're good. If you want to go down 1 over 1 again, you can. But That part of it will be okay there. All right, 9 and 10. Here's where we're kind of bringing them in from the other side. That we've got to put these in y equals mx plus b form, which means now we're trying to get this y by itself. So now we got to get rid of this x and move it back over here. So we're going to subtract the x from both sides. So we've got 3y would equal negative x minus 15. And then we need the y by itself. So if it's times 3, we're going to divide everything by 3. Okay, so it leaves us with y equals negative x over 3 minus 5. Okay, so for our slope, that's the numbers that's in front of x. And again, technically, there's not a number in front of x. So we've got the negative there. But anytime there's not a number there, just remember, technically, there's a 1 that's in front of that x. So your slope would be negative 1/3. And then your b value would be at negative 5. Okay, so this one would begin at negative 5. 1, 2, 3. And the m is negative 1/3, so we're going to go down 1 over 3 from this point. So down 1 over 1, 2, and 3. Okay, and then one more. Okay, that's what we'll do for number 10. Go ahead and give number 10 a try. See what you can come up with. And then, okay, so first thing is, again, just rewriting it in y equals mx plus b form. You can do it a couple different ways. If you kind of like the y being on the left-hand side, if you want to subtract the 4x, you can do that. So you got y minus 1 equals negative 4x. And then you could add 1 to both sides. Okay, if you go that route, your m is negative 4. Your b value is 1. But again, when you move it, you have to have a up, down, and a left, right. So in that case, if they just ask for the m value, it's okay to put negative 4. But when you actually turn around then to graph it, you got to think that it's over 1. So we're going to begin at 1, and then we're going to go down 4, and then over to the right 1. So 1, 2, 3, 4. 1 would put us there, and then connect those two dots. Okay. Now, and some of you may be okay doing this, some of you may not, just kind of depending on how it goes for this one. But where you had this equation, I'm going to show you another option you could have done. Since the only thing you need is you need the y by itself, is you actually could have subtracted the y from both sides. And that would have left that as 4x minus 1 equals negative y. And then you could have multiplied both sides by negative 1 to make that out to be a positive. So that way we made it negative 4x plus 1 equals y. You get the same answer. Just, sometimes if that had been a positive y instead of a negative y, that would have made this thing a whole lot faster because you wouldn't have had to move two things, just move one. But in that case, it probably was about the same either way, which way you go there. So again, there's always, most of the time, there's more than one right way to get the answer. So, that's one option you could have done. You could have just moved the y value over instead and gone that route. But, as long as you get back to the same answer, it's okay. Okay, now we're back to those trick questions again. We got vertical and horizontal lines. Okay, now from what we had back here on our other paper, okay, that's a vertical line, right? So what kind of slope is it going to have? We said vertical line was going to be no slope or undefined. So we know this thing is going to be no slope or undefined. But then we got to kind of figure out, okay, what's it going to be in this case? Okay, now here's kind of my thing. If it's vertical or horizontal, these are only going one direction, right? Because if you've got these lines here, they're tilted a little bit up and a little bit down and a little bit left and a little bit right, correct? There's a little bit of tilt one way or the other that you can say this is up and down. It's also a little bit left and right as you go through this one. In this case, this is only going one direction, right? It's either vertical or it's horizontal. There's no tilt to it where it's got a little bit of vertical and horizontal kind of, pitching yaw if you're talking about, you know, flights and other stuff with it. So to me, in this case, since you're only going one direction, so horizontal vertical lines, they only go one direction. So that means you only get to use one letter. Unless you were talking about the band, then they went like five directions, but that's different. That's a whole different ballgame. Okay, so here's what we're gonna do. I'm not gonna tell you the way because I used to get this messed up when I was in y'all's shoes, and it took my high school teacher probably when I was a senior. I finally got it figured out which way it was going to be and didn't do it backwards. And I'm not going to tell you because sometimes if you do that, you kind of learn it wrong. So I'm not going to tell you how I did it wrong. So here's what I finally figured out. Which axis does this vertical line touch? Hits the x-axis, right? Where does it hit the x-axis? What number? There you go. So they ask you to write an equation. You tell me what axis it hits. You tell me where it hits it. You're like, oh, that's it? Like, yeah, that's it. Just tell me where it hits and what value it's going to be. So anytime it's a vertical line, it's always going to be x equals some number every single time. If it's a horizontal line, it's always going to be y equals some number. You just have to tell me what number it hits the y-axis on. So for this one, that's going to be y equals 1. So there you go. Again, for this case, the slope is 0. And remember, those are two different answers because sometimes, depending on how you get these and what it does and how it kind of turns around this part, sometimes people get confused and they're like, oh, it's 0 and no slope's the same thing. No, it's 0 and no slope are two different answers because, again, it's how you can roll the ball as you kind of think about this. Okay. And one other thing you could do, and here's what I used to get wrong on this one. And actually, when we start graphing these a little bit later on, I'll show you some other stuff on this one, kind of a trick of how to get those if you ever get confused. But we're not graphing those just yet. So once we get to the point where we graph those, we'll show you that one. All right, last couple of things here at the bottom. It says slopes of parallel lines are. If you think about parallel lines, what do we know about parallel lines? All right, they never touch, right? That's the one thing we've always known. But what's the same? What parallel lines actually have the same thing? They have one thing that they have in common. What would that one thing be? I think somebody said they have the same slope, right? Yeah. So when it talks about the slopes of parallel lines, the slopes are the same, or they're equal, or whatever you want to call it for that part of it, because they're both going in the same direction and they're both going at the same speed. If you want to call it that, that's why they never touch because they're moving exactly the same speed, same rate of change, same whatever you want to call it there. Okay, and then perpendicular lines. That's where you get, they make an X that everything's at right angles. This line is positive and this line is negative. So they have two blanks. To me, I kind of do it this way. We'll say that they are opposite sign. Because if one's going to be positive, the other one's got to be negative. Because if you're making an X, it's got to be that way. And then the other thing is that for the way it sets up, they're also going to be reciprocals. Okay, so which means that if one of the slopes is 2/3, and they ask you, if this line's 2/3, that means this other line's 2/3. Okay, that's easy. But if it's perpendicular, if this one's 2/3, the other one is you're going to change it, give me the opposite sign. So instead of being positive, this one's going to be negative. And then you flip this thing upside down and make it negative 3/2. So whatever the first slope is, you change the sign of it and you flip it upside down, and that tells you what the other line's going to be. All right, and we're just about out of time because I think we're actually going to move to homeroom so y'all can get report cards here in a minute. So what I need for you to do for homework is you've got 4 problems here at the bottom. And we may see if we can get the first one in together. What I want y'all to do is to do those problems just for homework, bring them back in so we can talk about them next time. And we're going to see if we can get through the first one before the bell rings so we can kind of get through this one. I'm going to